Hi again, everyone. Tom McNamara here for our course in college algebra. In today's video, we are going to talk about the concept of an inverse function. So by the time this video is through, you should know what inverse functions are intended to do, and you should know how to write the formula for the inverse of a given function, at least in simple cases. We'll have a follow-up video to this where we cover more complicated cases. But here's the basic idea. And this is a concept that goes all the way back to the beginning of the course. So you'll remember what the concept of a function is all about. A function is basically a rule for taking every element of the domain, which is the set of all possible inputs to the function, and matching that element up with an output in the range. And an inverse function simply goes backwards. So the inverse function starts with the output and tells you the input that you need to start with to get that output. So inverse functions are very useful when we are working backwards. We know what we want to end up with. We want to figure out what do we need to start with to make that happen. That's when the inverse function comes in handy. Now, when you are doing this process, when you're working backwards, you do need to think kind of carefully, because you kind of have to undo things in the opposite order in which you did them. So, given this process, and let's think about something that's just a kind of an everyday life process. So given this process, find the inverse. Okay, so this process is you get in your car and you turn the engine on. Get in your car and start the engine. Now, if you're talking about the inverse, it's not leave your car and then turn off the engine. I mean, just in a practical sense, you can't do that. If you leave your car, how do you turn the thing off? You have to turn the engine off, then leave. So the first thing you undo is the last thing you do is the first thing you undo. Okay, so the last thing you do is the first thing you undo. So given that over there, this is our inverse. Turn the engine off. And then get out of the car. Okay, turn the engine off and then get out of the car. So look at the steps you do in your process and then start undoing them backwards. So the last thing you do is the first thing you undo, as we see right here. So let's look at an example or two where we have the formula for a function. So quick example. So given f of x equals 3x minus 1, find a formula for f inverse of x. Okay, so that is the notation for the inverse function. It's the same function's name, but there's a little -1 there. Okay, so let's think about what f does. So the process for f is we multiply by 3, right? Remember our function notation. This expression over here is a rule telling us how to compute the output. So this rule says whatever input you're given, you multiply it by 3, and then the second thing you do is subtract 1. And if we look at the process for f inverse, let's follow the principles that we just discussed. The last thing you do is the first thing you undo. How do you undo subtracting 1? Well, you add 1. How do you undo multiplication? You divide. So f inverse of x is you take your input and you add 1, and then whatever you get, you divide by 3. Okay, let's do a quick application. Let's try this. So we are given a challenge here. We are supposed to find x so that f of x equals 35. So we're given the output that we want to hit, and the question is, what input should we use? Okay? So the way to do that here is this right here. So to say f of x equals 35, well, if that's true, then we must have this right here. Okay, x equals f inverse of 35. Okay, notice that I moved the function over, but I didn't really move the function over. I really applied the inverse to both sides. Okay, so I want to find an x such that the rule for f takes me over to 35. Well, based on what we know about how inverses work, the inverse function would take me back and give me that input. So the input I should use is f inverse of 35. And since we have a formula for f inverse, which says you take your input and then add 1 and divide by 3, we can see f inverse of 35 is 12. So x equals 12, okay? And we can very quickly check that if we did use x equals 12 in this formula, 3 times 12 is 36, minus 1 is 35, just like we wanted right there. Okay, so the idea of an inverse function. Now, this business right here, very easy to understand. I would recommend you only apply this type of thinking when you have a linear function like this. As the functions get more complicated, finding the inverse can be tricky. So we're going to look at some examples of that in our next video. But this is the basic idea of an inverse function. It's a new function that undoes the changes your original function makes and gets you back to the starting input. And these inverse functions are very useful for solving equations. Okay, and we're going to be dealing with equations that have unknown exponents in a couple of videos. And the only way to solve an equation that has unknown exponents is to use the inverse of an exponential function. So this type of thinking is going to really come in handy when we start dealing with that.